Okay. Oh,
Okay.
this is great. That way I can see what everybody says. Awesome. So like I was saying, we have electrical activity in the brain, the heart, and the muscles, and we used to think that these systems were they work separately. They were completely. They were not the same. They had nothing in common. Thanks to a lot of research and thanks to the evolution in technology, we now know that there's we can measure actual neuroscience. We can measure the actual how the brain is working, how different systems within the nervous system are working by measuring the heart and the muscles. So, for example, once we are in a situation where you're doing a presentation and the Zoom technology has an accident, and you are watching a movie and you feel very scared, or you're like walking down the streets and you see a dog, you have some sort of like a natural response, which we call it the fight or flight response. Okay, when our system goes into panic, into alert, into danger, something is happening. But we also have another system that works when we particularly after we eat, when we're calm, when we're very relaxed, which is the autonomic nervous system, which is the rest and digest system. Okay, this autonomic nervous system is the opposite of the fight or flight. Okay, it's called the parasympathetic nervous system. And now we know we can actually measure how this system is working by measuring the heart, by measuring your heart waves. The same with the muscles. The muscles are not individual units that just work individually. They receive information from the brain. And now we know there are nodes or conglomerations of this neural information, of this electrical activity that are called muscle synergies, that are in charge of actually sending information to the muscles. So when we are walking or reading or basically playing a sport back in the good old days, okay, you don't have to worry about how your brain sends the information to every single muscle, or when you're speaking on the phone while walking, like, okay, muscle one, muscle two, you now have synergies that are sending information to these muscles so you can do the activity. So real quick, an outline of the talk. I'm going to talk about concussion of mild traumatic brain injury. For those that have seen the movie with Will Smith, it's a very good movie. Then we're going to go over the methods, very briefly speak about some of the preliminary results of one side of my investigation, and then we're going to discuss and happy to answer questions. So far, so good. Everybody hear me fine?
Yes, we can hear you.
Perfect. And so what is a concussion? What is a mild traumatic brain injury? As we can see in the photo from the upper left, okay, the brain is not attached to the skull. It's not attached to the bones within your skull. It's floating. Okay, so imagine if you're driving and you know something happens and you have this rapid stop. That change in forces, that acceleration and deceleration of forces, okay, it's gonna make the brain hit the skull from the frontal part, very, very important for movement and personality, and then the part in the back, very, very important for vision. Okay, so you can, when we think about concussion, don't think, oh, you know, it's someone got hit, you fall, someone knock you, someone throws something at you. You can also have a concussion by what we call whiplash, okay, by acceleration and deceleration forces. When we see in the slide in the lower left, that is the typical side of a traumatic brain injury. Okay, concussion would be the mild traumatic brain injury. Okay, not as the moderate or severe traumatic brain injury that ends people in coma. And the reason why we think, okay, it's not a big deal, it's mild traumatic brain injury, actually, because that's the main issue, because the symptoms are not so obvious at the beginning. People are not necessarily bleeding, people are not necessarily, you know, with a big headache. It's more of a confusion, a dizziness, a disorientation. These are invisible symptoms that are actually hard to detect. because they're hard to detect, they become a problem on their own. That's why we have a lot of people suffering from post-concussion syndrome, or a lot of people suffering a lot of experiencing a lot of emotional, a lot of psychological symptoms, a lot of like sadness and depression and anxiety and things related also with your physical, like a light sensitivity. Like right now, just went up and turned on the lights so you guys can see me clearly. A person with a concussion that just suffered, had to wear sunglasses. They wouldn't be able to sustain the light, depending of the gravity of the symptom. I don't know if you've seen in the subway late at night, someone wearing sunglasses or very, very dark colored glasses. Those people usually have light sensitivity issues. And though a lot of those people, what we call the experiencing photophobia, happen because of a concussion. So think about 2019. In the United States, both the military and the sports are a big part of the culture. And that's where we see most of the concussions. And there's an interesting thing that happens with both populations. So I don't know if you have friends that are athletes that play football, play soccer, they really want to go to college. What we see in sports concussion, in people that suffer a concussion by playing sports, mostly here in Long Island, it's lacrosse, but also football, soccer that we call real football, if you're international world football, and also volleyball, hockey. You can see that those individuals that suffer a concussion, they really want a scholarship. They really want to pretend everything is okay. So they actually underplay their symptoms. They're not necessarily truthful or honest, or they cheat on their baseline test before season starts. So when they actually had a concussion and they get tested, you don't see a difference. Same thing happened in the military, but the opposite. Okay, you see a lot of people trying to, when they're in combat, they're soldiers. A lot of individuals do experience mild traumatic brain injury or concussion. I want to use them interchangeably. Especially the famous blast injury. A bomb explodes 10 meters down the road. That gravity, that impact forces, that causes the whiplash. A lot of people in the military actually do the opposite of sports. They pretend, and it has been documented, they pretend they have symptoms, they exaggerate the gravity and the magnitude. So there's really a need to screen it. When we talk about a biomarker, okay, we really need some sort of a better diagnostic tool that can actually measure concussion. Lastly, as we can see here on the right, in the upper is just CDC numbers. These are just the ones that are diagnosed. Okay, so imagine this is a very underdiagnosed problem in the United States. When I said that it's people experiencing fake, I mean during combat. So we have 3.5 million concussions. Okay, according to the CDC, one concussion increases your chances by 50% of suffering a second concussion. That means of every 10 people that suffer one concussion, 5 people are going to get a second one. And up to 12% of people suffer up to 5 concussions after they suffer the first one. So why is this important? Because maybe the first time you experience a brain injury during youth, the plasticity, the changes within your brain are going to make sure to, take care and clean up the scars. But then you're going to have a lot of problems down the line if you had more injuries. You can actually have permanent damage that will carry on all the way to through age. We see concussion very related with Parkinson's disease. We thought it was very related with Alzheimer's, not so much anymore, but we see a lot of association with a lot of people that suffer big major deficits in memory at their age, when they're old. We also know that 80% of the people that are incarcerated, that are in prison, they have some sort of head trauma or brain injury or concussion that they experience in their lives. It's mostly common in men, from 2 to 1, based on the personality or the reckless behavior that men often show. But in women, post-concussion syndrome tend to last longer. The last image that I have on this photo with the Times Square, back in the good old days, and it's that Times Square is like, for me, coming from Venezuela, is my favorite part of the world. Just remember when I was there for the first time, saw the lights. But it's also a nightmare for people that had a concussion. Just imagine walking from the Hard Rock Cafe all the way to the Red Stairs from 42nd to 49th. You see all the people, all the lights, all the noise, the cops, naked cowboy, naked cow woman, the mini Mickey Mouse. You know, that environment, it's completely detrimental to somebody that suffered a concussion. And when I speak about that environment, is that we tend to think that people that suffer brain injury, they're okay if they're able to walk down a very peaceful, without obstacles line, you know, with no barriers, no noise of 10 meters, and say, oh, you know, they're fine. But you know, we have to make tests more challenging. We have to make scenarios in order to diagnose and actually monitor the progression of this condition, sort of like the Times Square, or sort of, you know, mimic, you know, scenarios in which they actually gonna, you actually challenge these individuals. When we talk about biomarker, a biomarker is a signal, okay? It's a biological signal that means something. So a biomarker for a disease could be when the doctor says, open your mouth and you see the sore throat to see if you have streptococcus, okay? That image is what the doctor sees in the throat could be a biomarker of that condition. So when we think about biomarkers for concussion, they are very expensive. They don't give you real-time data of like, okay, like a test, like in 5 minutes you get one. They're usually either, as we can see here in the upper right, either an MRI or a functional MRI that it's not anywhere in the country. It's not so much in the rural areas. There's also problems with claustrophobia, with the radiation. They tend to measure more the structure and not the function of the brain. And I don't know if you've seen the difference, like the controversy, structure versus function, but there are also a lot of functional MRIs that are also very expensive. They're used for research. They're not necessarily prescribed or recommended by the doctor, and then seeing the insurance can afford. That's the situation on the right. The situation on the left, we see another type of biomarker, which they use blood samples, where they take parts of they take a blood sample and they take it to the lab, to the wet lab, to the bench, and see if there are specific antigens, specific proteins, specific growth factors, specific markers that says, yes, there is injury in the brain and there are problems happening. That's what we have to make more realistic biomarkers. So in this slide, as we can see, that when you have a primary concussion, it increases your sensitivity, what we call your susceptibility, your ability to suffer more danger, changes, and problems, okay? This susceptibility, you can have a thought process, what we call cognitive deficits. You can have physical deficits, we call motor deficits, usually posture or fatigue, physical fatigue, dizziness. They're with that, and they're also attention deficits that we tend to overlook these deficits because, okay, the millennial generation or the Gen Z, Gen Y, we're very technology driven, we're very technology savvy. So a lot of people tend to overlook attention deficits, and we either think everybody has ADHD or everybody is just, you know, unfocused. But people that suffer a concussion, these attention deficits, they can be very, and I want to make an emphasis on this, they can be very, very dangerous. They can be very, very dangerous. They can increase your risk to fall, having a second concussion, and therefore a permanent brain damage. Okay, that's why it's very, very important to catch these symptoms before. Now, let's look at one of the main motor deficits that doctors collectively have chosen to ignore recently, and which is balance, which is postural balance control. And let's look at, okay, we have balance in the center. Let's look at all the systems that contribute towards balance. For you to maintain posture ability, like if you're in the movies and you're online, for you to maintain that posture ability, that center of gravity without falling, and without, you know, if something happens, you have something, you know, within your body, you don't automatically fall, you have something that actually keeps you. You need information from your brain. You need contributions from your muscles. You need information, what we call the muscle memory, your body schema. You need information from your sensory systems, okay? Now we know the cerebellum is involved in balance. Now we know it's the motor cortex contributes to balance. Now we know that this part of the brain, the prefrontal cortex, okay, that is related with personality and with the ability of controlling emotions, also contributes to balance, okay? Balance, postural, control, stability. There are two types of balance, the ones that you have during posture and the ones that you have when you walk, they call dynamic balance. You usually see when you read a paper, they call it gait balance or dynamic reactive balance, okay? But this is a very problem that drove the information in my research. So a main problem is that we lack this objective, practical, when I say practical, easy to do, feasible, and not that expensive, okay, diagnostic tests to measure concussion, to measure mild traumatic brain injury. That's what the research questions, as you can see in the slide. Can a more systematic balance test serve as a new, more objective? What do we mean by systematic? That instead of a right or wrong, you actually do an actual calculation of step by step of the contribution of each system. So when you see the word systematic, look at the slide before. A systematic way would be a way of trying to measure all the other symptoms, all the other systems that contribute to balance one at a time or two or three at a time, as opposed to just balance in general, as opposed to a yes or no. You can say there are more systematic tests than others. Now, electrophysiological. When I say the word electrophysiological, it just means electrical activity within your body systems, within your physiological systems. In this case, brain, heart, and muscles. And also, three, if you have one thing that we know in neuroscience, if you have a behavior and you have a biological symptom, what is the link? What is the mechanism? That's what a lot of people in neuroscience research do, especially they do it more with the people, the neurobiologists that study molecular neuroscience in the labs with mice or rats or flies or cell cultures to study these mechanisms, but we also can study mechanisms in the human, okay? When I say I'm a translational neuroscientist, it means I apply neuroscience to try to solve world problems. You can be a translational neuroscience working in the media. You can be a translational neuroscience working in pharmaceuticals. There's a lot of translational neuroscience working right now to diagnose COVID-19 or to work with vaccines or with devices that actually are going to be able to deliver the vaccine more effectively and actually make sure the vaccine works. We see a lot of symptoms that COVID-19 in survivors that are within their neurological system. So it is important that neuroscience contribute to society every step they can. So what I did for my research, I said, with my professors, let's challenge the status quo. Let's make more time square related tests. Okay, so as you can see on the lower right, we see the typical balance test of just the person doing, maintaining balance for 20 seconds, and then someone says, yes, pass or fail. Not very systematic. On the lower left, that's actually me. You can actually see that sort of like my experiment. We not only we're doing balance, and I'll explain this as we go by. We're actually doing many tests of balance differently in either a firm surface or either a soft surface. A soft, imagine like a cushion, like a pillow, like maintaining balance over there. Why? Because it reduces the information, the input, the contribution of the receptors within your ankles, and it makes maintaining balance way harder than with it. And at the same time, if you look at and I think I have a video of it, you see all these electrodes. I'm measuring the activity with 3 different devices of the brain, the heart, and the muscles, what we call the triple electrophysiological tool. It was a novel way of measuring this. We have published a couple of papers pending. We're still working on analyzing the data because there's so much data that the research generated by measuring 3 systems at the same time. When we look at the upper screen, okay, at the upper left, you're seeing what I'm seeing. They're tracking the measure, they're tracking your balance. You get information of how well you're actually performing the task. Okay, so over here on this slide, that's me. If you see the yellow arrow, it's what I told you that the typical participants see. They're maintaining their balance. When we see the first red arrow, I don't know if you can, can you see the highlighter, what I'm pointing at? Anyhow, the first computer, yeah, got it. The first computer in front of you, that one is measuring the activity of the muscles within the legs. And if you see the middle left arrow below pointing to an electrode, that's the leg. Okay, that's measuring the muscles activity in the leg, and it's been recorded in the computer that we see on the left, the first one. That one is measuring the muscles, and it's also, if you look at the first row, it's that continuous, that steady lines. That's the heartbeat. It's measuring the heartbeat at the same time. Okay, let's see if the video plays. Is playing the video?
Yeah, it's playing. It's just a bit slow.
Okay, perfect. The video, while I'm not only maintaining balance, but I'm doing a cognitive task in my head, what we call it the dual task, okay? Which is just not enough to maintain balance, but since there's contribution from your prefrontal cortex, from your cognitive systems, I wanna knock that out. I wanna reduce the contribution of it. I wanna see how that affects balance. And we know that a lot of people that suffer a concussion, they're mainly suffering cognitive symptoms. They're mainly suffering memory, attention problems. So to slide above, what is that cognitive task? Okay, it was sort of like a arroz con pollo, like a creation of specific mental tests, okay, that measure memory and attention. So what we do is that we give the participants, and in the video, one of the computer was actually the one, with a very robotic voice telling them. We give them an alphanumeric sequence of 5 digits. Okay, like if you say R2D2X, and we say repeat it backwards, but not right now, in 20 seconds. And that increases the level of difficulty because it means that the person has to retain the alphanumeric sequence in their head for 20 seconds, manipulate it while they're doing balance, and then repeat it backwards. Okay? Repeat it backwards exactly as in the exact reverse sequence as it was given. So if they would have made a mistake, like if instead of W8, H7X, if they would have said 7X, H8W, that would have counted as 2 errors. Okay? Because they're inverting the sequence. The maximum number of errors you can get is 5, and if the participants, took their time, or you see that they were guessing, like X7H, we repeat the trial because it wouldn't actually be data. We wanted to see their working memory and their attention when it's challenged, not their guessing abilities. So with the motor system, remember when I said the word systematic? Okay, we do these 6 tests by themselves, and then we do the test with the memory task. Okay, so it's not like we're having the participant coming and making them. We explain the reason and the purpose that we want to measure better concussion, that hopefully one day, thanks to this, we can save people's life. But we're also training them. We don't want to see learning throughout the task. We don't want to give them the hardest, we don't want to give them organic chemistry too before they know the basics of general chemistry. So we go step by step on a very systematic way. The first task, and that's the video that you guys just saw, it was at the firm platform, okay? They were maintaining balance at a firm platform, which is just the floor. However, reducing their center of gravity, feet together, and hands in their hip. if you try to do it, it's way harder than just maintaining balance. You know, kind of bend on a side. We put our legs separately, and we obviously, you know, you're always doing something with your arms. We know that there's research that shows that the way you move your arms affects how you move, affects how you walk. So it's not automatic, this task. Okay, maintaining balance with, even if it's on a firm platform with your eyes open, it is a little bit challenging than most tests because of the reduction in their center of gravity. Okay, by their feet together and the hands in their hip. However, all systems are contributing. You have contributions of the cerebellum, you have contributions of your motor system, your sensory system, the vestibular system. I don't know if you heard about the vestibular system. It is very important, what we call equilibrium, what we call balance. And it is a cranial nerve. It is also within the, like anatomically speaking, yes, it is with the auditory channels, with that of your auditory system. That's what some people, when they have an infection in their ears and they don't catch it, and they have the infection for years, some people, you know, they have a weakened vestibular system. Those people experience problems in balance and equilibrium, and they don't necessarily have to suffer a concussion, but they did suffer those. They do have a damaged vestibular system because of the infection. So that's the first task that we did. Then we have them to do the exact same thing with their eyes closed. Why? Because we are very visually dependent. And I'm not telling you to do this as an experiment, but you know, if we don't, like most people, you need to see what you're doing in order for you to maintain the posture, in order for you to maintain your ability. So don't go and try to, you know, shower with the lights out, no, but it is, we know we're very visually dependent. Then we do the other two tasks, the same, eyes open and eyes closed, but with a catch. We put like in, I don't know if you can see the yellow arrow below, like it's like below the bench. It's like right behind me. That's a cushion. That's a cushion that we put on top of the firm. Okay, because within the firm, within that system, that has the sensors for you to track how the person is moving, how the person is maintaining their balance. And funny story, you can put a rock like over there, like, and it will measure it as zero balance, zero sway. And you can also go there and dance, like, I don't know, a song from Shakira, whatever, and the more you move, you have an incredible number of sway. And yeah, I say Shakira because she's from Colombia, next to my country. That's the closest thing that I could think of. And then the last two tasks that we see there in green, they are heavy. I'll explain them later, but they're basically not anymore maintaining their balance on one position. They're actually shifting their weight. Before they do this, we want to know if they're right leg dominant or left leg dominant. Just as basic information, if you are right hand dominant, that doesn't mean you're right leg dominant. The dominance within your legs is really depends. And we do a separate test. We either throw them a ball that they can, football, global football, soccer ball that they can kick, and then we do some sort of pushing or holding, and we see what's the first leg that they use. And we do it separate repeatedly, because most people, like if you ask most people, are you right hand dominant or left hand dominant? They know how they brush their teeth or how to write. And most people are right hand dominant, but with the legs it's completely different. Even if they're athletes, there were a lot of surprises there. But for this task, we actually make them shift towards their dominant side, which means they have to hold on more on their non-dominant leg. Okay, and then we have the combination of the two set of problems, the two set of tasks, the balance task with the cognitive task. Okay, so imagine doing, that's what it's very important to work systematically. Imagine doing the repetitive series of everything, of all those balance tasks in combination with the cognitive task at the same time. So while they're maintaining their balance, okay, in every single condition, each of them is 20 seconds, and there are 30 seconds between the conditions, so they can, you know, take a break or breathe or drink water. And trust me, some of them did. And even healthy controls, they were like, you know, it is a challenging task. It It was difficult to complete. We didn't harm anybody. It was an inclusion criteria, very, very subtle. They had to show that they have to maintain stand for 10 minutes. They have to be able, like, to pass a mini test so they can actually, be eligible for it. Because we don't want to cause, especially for people that suffer a concussion, we don't want them to experience post-concussion symptoms. We don't want them to pass out or have a headache or to, vomit in the middle of the test. But with the combination of the two, there are the single complex task, okay, in which they were maintaining balance while doing the cognitive task. Okay, so even though they're doing two tasks at the same time, the brain only calculates as one complete whole, as just standing and repeating back the numbers. That's what we don't call those the dual task. The dual task, okay, are the two conditions in which they have to shift their weight towards their dominant leg. Okay, that's what your brain is responding and is calculating as two separate tasks of you shifting your weight towards one side, physical, while repeating the numbers at the same time. So dual task, the brain is repeating, is calculating two tasks, is differentiating that you have two different goals. One of shifting your weight and the other one of repeating the numbers backward. Very different from the single complex task that if you ask people, well, this is a dual task, I'm doing, I'm maintaining balance while repeating the numbers. I'm like, yeah, not really, because you're only standing balance, you're not just resisting, it's just sensory information, you're not actually executing a motor output. So we got 10 healthy controls, and we call healthy controls people that never experienced a concussion. And it's very, very important in clinical research, and that's what you see a lot of clinical studies that they take forever to be completed, because especially in neuroscience, when you talk about healthy controls, these are people that don't have either they have experienced mental illness, or they have experienced any other neurological disease. They're not on any medication. They have slept very good the day before. So it is challenging. And also with the post-concussion, with people that suffer a concussion, a lot of them had a concussion years before, because someone that had a concussion 3 months before, just by explaining what they have to do, they're gonna be, hell no. It could be challenged, but safety is number one, ethics is number one. We were always there monitoring, making sure no one fall. We always have practice with them for them to see if they can do it, and also to make sure that the data that we have, it's actually meaningful, that it's not just learning. Like if they got better from task to task, it was because they were just learning it, as opposed to actual showing their performance. But we had these three hypotheses. We predicted, in short words, that the concussion, the healthy controls were going to experience, and they were going to do worse. They were going to do worse in all tasks. So in balance, they were going to have more sway. Sway means more shake, less posture, less stability. They were going to have more mistakes in the cognitive task, and obviously. I'll get back to the dual task effect, but when they actually get to do the dual task, their performance in both were gonna be worse. There's gonna be interference from their cognitive and their motor system. So the way they were doing their cognition, it was gonna affect how they were doing their posture, their balance, and backwards, or vice versa. And with the 3 electrophysiological tests, okay, with the EMG, with the muscle electrode, we were going to see differences between the synergies, okay, the synergies, the group of muscles that we measure, the group of muscles that are all working together at the same time to try to coordinate an action. So the pressing with a remote, one finger, the on channel for the television, that's not a muscle synergy, that's an actual individual unique muscle. But you talking on the phone while you are walking, that's when you have muscle synergies, okay? You actually, while speaking and drinking a bottle of water, and you're still talking on the phone, that's when you have synergies working. When you have group of muscles as opposed to just one individual. So when you think about synergies, it's just a group of muscles that are working together because the brain just sends one input to the node, to the synergistic node, as opposed to each muscle separately. With the EEG, with the electroencephalography, we're gonna see changes in the motor cortex in one specific area, the motor cortex in charge of movement. With the EEG, we cannot really measure subcortical areas like the amygdala, which is involved in aggression, or the hippocampus that is involved in memory. We cannot. We can only measure the cortex, okay? Either your frontal lobes, the motor cortex within your frontal lobes, the parietal, the temporal, the occipital lobes. And then with the heart rate variability, remember when I was talking about rest and digest, okay, of your parasympathetic nervous system, okay? We are actually seeing a lot of studies, especially with sports concussion, that even years after they suffer an injury, they have different heart rate variabilities. So not heart rate, but heart rate variability. And this is an indirect way of measuring your autonomic nervous system. So just basic information of their age. They were all within their 20s. Look at the amount of time since injuries in the concussion group in red. Some of them had a concussion 16 years before they were pediatric concussions. So they suffered an injury during development. And they experienced symptoms for like 5 days. I think the worst case was 13, patient number 3, that actually had 3 concussions in their life. And the first and the third one were worse than the second one. They experienced symptoms for 2 weeks each, as opposed to the second concussion that it was just 1 week. And that's what they can remember. So real quick, since I have just 3 minutes left, just gonna go briefly with the results. These are the results for the balance. Y-axis, we see the sway deviation. The higher the sway, remember the Shakira song, the higher the sway, the worse the performance, the worse the balance, the more they shake the most. On the X-axis, we see the 6 conditions, okay? This is just single task, there's no memory, there's just try not to fall. The ST5 and ST6 are the 2 conditions in which they have to shift their weight towards one side. Okay, they add increased difficulty, especially with the eyes closed, because with the eyes closed, they have to basically, see the target on the screen, shift, and then close their eyes and maintain it, and remember that the target was there. They were using physical memory. They were using proprioceptive intelligence in order to maintain that. What you see in the white bars are the healthy controls, and the black in the concussion group. We see in this slide that both groups did horrible. They did the worst in the condition that they have to close their eyes, and they were on top of a cushion. The other 2, when they shift their weight, we didn't do that on top of a cushion, on top of the foam, of the pillow-like platform. We actually practiced it ourselves. It was like too difficult. We were gonna get like a floor effect. There was no point. Then we see the exact same thing for the single complex size. Look how the ST4, which is the one that they have to close their eyes and they have to be on top of a foam, both groups did worse than the others. Now, a comparison of the single task with the dual task. So on the left, we see ST5 and ST6. It's the exact same bars I showed before. DT1 and DT2, they are doing the exact same behavior. Everybody here is shifting their weight towards one side. However, on the 2 ones on the right, the DT, they're doing the cognitive task at the same time, okay? And notice how from DT1 to DT2, okay, there was the groups basically changed their performance. The healthy controls show that they did worse than the concussion group, but then you look at the massive, and that's the arrow, that's the line on top of the white box. You see the massive standard error calculations. You see that there was just a lot of variability within the group. You see that there were 2 or 3 individuals within the healthy control that did just horrible, and they shift and they skew the group and it seemed like they did worse than the concussion group as a whole, but it was really just the outliers. Okay, same thing for the cognitive scores. We have the single versus the dual task. So again, the y-axis, now it's not the sway, now it's the number of errors, but the same logic. The higher, the worse. Okay, the higher the number, the more number of mistakes, the worse performance you did in the cognitive task. Okay, and regarding the additional electrophysiological methods, just like I explained, the model, the muscle synergies, there are parts within your brain that control each synergies. Whether it's on the left, we see the synergy that is controlling at the same time the flexor and other two muscles. But that gray part over there, that gray circle, just like the red circle over there, those are what I call this, what it's called the synergistic nodes. Okay, the point of uniting, the coordinator. And think about it, the nervous system wants to be smart. No one works harder if they have to work easier. No one pays more money, they have to pay less. Okay, so why would the brain go with the hardest task of telling each muscle what to do if they can just, tell someone else to tell everybody what to do? So instead of you calling your friend each one by one, you create a WhatsApp group, you create an email group, you create an organization, and you deliver the message to make sure it goes through, as opposed to telling each individual person. That's sort of like how synergies work. And we also see there was no specific trend with the synergies, at least at the preliminary. This is just the basic information, the average and the standard deviations. We haven't seen differences between the synergies between the groups. And lastly, this is my last slide, I promise, with the EEG that measures your electrical activity. It also measures your electrical connectivity, like how different parts of the brain are working together. We're also working on analysis for that. And we're even working on analyzing how the connectivity between different parts of your brain were connecting to the synergies within the muscle. So that's going to be a very, very cool paper. It's the corticomuscular coherence. Coherence just means connectivity, communication, how the different parts of the brain are talking together. The same conflicting results. And with the EKG, it was a way of saying, okay, instead of explaining this part of the results, let's just go with feasibility. Like, why would you, wouldn't it be great if instead of measuring, concussion or any disease, if instead of putting what this individual has on top of his brain, all these number of electrodes in it, if you can do all that, if you can get away and get the exact same response and information with just one electrode, wouldn't that be easier? Wouldn't that be more convenient, cheaper, cost effective, better for everybody? That was sort of what we try to do, different methods at the same time. Okay, this is just to show there was, when we do the statistical differences, there were differences between the two groups. We call the Bonferroni, also Italian. But main conclusions is that the method was safe, was effective. Okay, they are novel tasks, are new tasks, are design tasks that we, follow the trends of conventional standard methods. Okay, and we have to continue with the analysis of the electrophysiological variables, and these are future directions and limitations from a year ago. We're working on it, on top of them, but it's basically introducing more computational analysis for the methods, and to analyze how the variables working together, or what are the relations, as opposed to one at each time. So thank you very much. This was me with my cohort and my mentor back in 2015. We were four from the United States and two internationals, me and my colleague from Ghana. And this is where I'm from Maracaibo. That was Christmas, back when all my grandparents were alive. And on the right, it was me on my graduation day. That was last August, when my siblings and my mom came from Venezuela. So happy to answer any questions. Sorry, I went over time.
It's fine. You can take as much time as you needed. Okay, so if anyone has any questions, feel free to drop them in the chat now, and then he can read them and respond.
Or you could just unmute your mic and say it.
I guess I'll go first. My question is, what advice would you have for anyone trying to get into neuroscience?
It's worth it. It's absolutely worth it. It's a passionate career. It's a career growing. Don't get frustrated. It's not an exact science. Don't get frustrated. 2 + 2 doesn't equal 4 all the time. So if you are more of engineer mentality and you want concrete answers and you want like fast results, know that you have to be patient. That that there's a lot of room. That most things you see, you're gonna see long-term results. Okay, and it's very important right now. We have an aging population. An aging population is more likely to suffer dementia and symptoms. We have an increase on disorders such as the opioid use disorders that is basically an epidemic. We're living through an pandemic, but also we already had an epidemic before. And things like concussion, maltraumatic brain injury, they're becoming more susceptible. So my 3 advices is, it's not an exact science, so don't get frustrated. 2 is definitely worth it because they're worth it to learn. The lessons are unbelievable. And 3, we kind of need you. We kind of need more people in neuroscience, and that doesn't mean you have to do a PhD in exact neuroscience. You can do a PhD in genetics, in rehabilitation, but you can do your research within the neuroscience field, and you will still be a neuroscientist. Same with engineer. You can do a PhD in biomedical engineer, but like the classes you'll take is in engineer, but your research would be in neuroscience. So there are a lot of ways to go, to become a neuroscientist that I think it's other careers don't have it, and there's more opportunities for.
Thank you.
I have a question. So individuals that have concussions, do they have an increased awareness of circadian rhythm, like their own circadian rhythm?
That's a very good question. There's a lot of problems in the endocrine system that individuals have. There's a crazy, what we call it a crazy paper, that in the late 90s, there were women that suffer a concussion or a maltraumatic brain injury. They varied the way their symptoms were based on the time of their ovarian cycle. So like the gravity of their symptoms after a concussion was predicted based on the time of in which day of the 28th day they actually suffer it. So with the circadian rhythms directly, there are definitely issues that they're also measuring heart rate variability. There's studies they measure different hormones like cortisol and stress. And the problems anecdotally that individuals have with circadian rhythms, and just know that circadian rhythms are usually abnormal for everybody. When they did a study on a group of people, like they live in an island without a clock, they noticed that their normal days, wasn't a 24-hour day, it was more of a 26-hour day. But individuals suffer a concussion that they need a lot of rest, especially for the light sensitivity, because and the sound sensitivity. Everything can become annoying and obnoxious, and they suffer from this irritability, which is they told me I couldn't even hear my own girlfriend or my own father chew food while we eat. They were very, very sensitive. So the circadian rhythms were not. I don't see it more of as an actual brain damage, but more of a behavioral response that they have to manage. Because if you have to go and the doctor tells you spend a week without television in a room, quietly in silence, they're gonna see on the run some circadian rhythms, a decrease in melanin, and yeah. Good question. That, as I said before, not an exact science, but it's definitely an angle worth looking.
All right. Okay, you can
Sorry.
go.
Thank you. So I heard that you mentioned light sensitivity. So you're also looking for like a effective way to like an effective biomarker. So would MRGCs be an like effective biomarker for concussions?
MRGCs?
Yes.
Can you explain a little bit more? The MRGCs?
So I've read of MRGCs and how a lot of people like in neuroscience when they're looking into or doing research on like diseases and conditions that are like, you know, in the neuroscience field, like they're looking into MRGCs. I don't know how to say like the words for what it stands for. But it's like they're like retinal cells, and like they're associated with like light and light sensitivity and circadian rhythms.
Yeah, motor cortical oscillation of the age-related. I've heard very, very little of that in concussion, but just by doing a quick search, it's more related with autism, the conditions involving the autism spectrum, like problems in communications, and at the protein level, just like I mentioned at the beginning of my talk, like what were the differences between like biomarker that is very expensive, like an MRI, or doing a DNA blood samples. I think the MRGC is just part of the big repertoire of possible markers and proteins that people can look to try to, you know, correlate it with traumatic brain injury, correlate it with concussion. And good luck. I haven't heard anything recently, and I don't necessarily think it's gonna be anything that you can do at the genetic level for a concussion. I don't think it would be revolutionary just because of the time it takes for you to actually get a response. It's not like a pregnancy test. It's not like an actual, you know, cognitive test that you can do and get the information right away. But it's definitely worth looking. The light sensitivity issues, it's not molecular. It's, you know, when you have the whiplash and you have the brain that hits the frontal lobe and the occipital, and then the part of the occipital lobe, that's where the light sensitivity issues come, when it's because of the diffuse, not the direct damage, but the diffuse damage throughout the brain, and that affects the white matter tracts. And even if you hit the front part, you can have damage in the white, you know, throughout your brain, in the white matter tracts that go all the way from your occipital. So since it's a very good question, but since it's more like my point of view, since the light sensitivity issues are more of a structural damage, I wouldn't see why, you know, analyzing light sensitivity problems at the molecular level are in need. But it's like I said, neuroscience is a beautiful field. A lot of discussion. Someone could disagree and say, yeah, I think we have something there.
Okay, thank you.
We have a question in the chat from Samuel. He's asking, how long do you believe it will take to have technology that could diagnose concussions and other neurological issues as fast as taking one's temperature?
Oh, I asked myself that question when I started grad school in 2015. And when I started grad school in 2015, we thought concussion was related with Alzheimer's. When I graduated, now we know it's related with Parkinson's. So things changed. To answer your question, I think with the technology already exists. I think the technology, we have it. I think there's a lot of computational labs, a lot of engineer labs that are measuring concussion. But then we get into another conversation, which is bureaucracy and how the system works, which is sometimes you have a lot of good medical technology and you have a lot of good defense technology, and the defense and medical technology, the two fields, sometimes they don't talk. What do I mean by this? Sometimes the NIH, the National Institute of Health, or the National Science Foundation, they found a lot of research regarding how to improve technology and how to measure things better, how to treat these conditions better. And then the Department of Defense, that has their field and their science, and they're also fund a lot of research, they tend to apply more the medical findings into the defense findings. Okay, so how to improve the military, how to improve the lives of the military personnel. This is extremely important. But the opposite doesn't happen at most cases. I will say it's like 80% of the times you have medical findings applied to the defense findings that the common population won't be able to see, what we call the med to defense technology. And only 20% of the time we see the defense to medical technology findings. When you see one of my slides, that EEG, the one that I have, it's very different from the ones you see from your doctors, because it was dry EEG. It was with dry electrodes. It doesn't require any gel. And guess what? It wasn't invented to study them in humans, to study them in the society. They invented them to study them in the military. So that was one of the tech to med applications, one of very few that I see. So to answer your question, I think we already have it. When can we use it? When it will actually be used in the common population? I think it will take years. I think sometimes there's it's not very convenient for big companies to how can I say this? This is uncontroversial. Sometimes quick findings, quick cures, quick diagnosis are inconvenient to have. So things just keep getting delayed. And there's also a lack of like things that can slow down this even more. And we don't see this for a decade or so, you know, diagnosing concussion as fast as we can measure temperature. That would be ideal. That would be a dream. The closest we can do is with the EKG and the heart variability. There will always be patent problems. There will always be lack of communication. There will always be, you know, intellectual property. There will always be, not everybody that is a scientist, it's very good, we're honest, or is very good at explaining science. And if you're a patient, and like if you're a mother and they're telling you that this new device or this new set of tools, they can diagnose you, the concussion in your daughter easily. If you don't explain it well, it doesn't matter if you have the best technology. Sometimes the public is going to reject it. But very, very good question. Tons of good questions.
We have another question in the chat. So Nafisa asked, what is the main cause for migraines?
Good question. They depends on the migraine. There's chronic migraines. There are, sometimes there's differences in the sensitivity of each individual. How do you measure pain? And that's actually, you know, some people think that they suffer from migraines because they are very big headache, and you know they have less tolerability to pain. Migraines have their genetic causes. They have definitely their environmental complications. Okay, those intensive headaches, and we're talking about the severe migraine headaches that just, like, imagine if you're doing a presentation, that big headache comes out of nowhere, and you just, you know, you stop talking, you have to like take 3 minutes to sort of breathe, or take the medication continuously. They can get worsened with stress and with an unhealthy side of life. If the root of the question was like, is suffering brain injuries throughout your life can be, you know, can account for a large number of people suffering migraines? Absolutely. It's the mild or moderate traumatic brain injury. The main the main symptoms you see, first, some of them become unconscious. I didn't say this at the beginning. Like, some of them can lose consciousness for like either a minute or like an hour or just 5 seconds, and they don't even remember that they lost consciousness. But we see that mental fatigue, those headaches, those migraines, and mental fatigue is very common in concussion. And when they when they say mental fatigue, it's that they're getting wear out and they're sort of like predicting that they're going to suffer a peak migraine. So I don't have a specific answer for that. So there are a lot of causes for the pain and the chronic migraine and inflammation. But I would suggest that those underdiagnosed concussions and head traumas that we live through our lives might account or might be, directly related with a lot of the cases that we have from migraine. Thank you.
Hi, I just wanted to go back to like the previous question with the neurological tech. I wanted to ask if you ever felt uncomfortable releasing your research to the military?
No, the opposite. You always want to show your research, and there's so I work in a rehabilitation lab. There's a lot of companies that they're medical device companies that they know they have contracts with the military. No, everything that is national security, absolutely not. It's a responsibility. 100%. You have to. I never feel like uncomfortable. I never no, absolutely not. Not even when you're like in the career fairs or when you're talking to somebody that was in the military. I have a lot of friends that were veterans. Never, you should never feel uncomfortable of explaining your research or what you do, or you always want to promote it and you always want to make people aware, or even if it's just for to provide common awareness and increase IQ and show different ways of think of different problems from different angles. And I wouldn't say that's the same for people that maybe study nuclear physics or they're working with specific formulas, or they were actually, I had a friend that was engineer for a company that only got contracts from the DoD for specific systems that they put in specific machinery. And I know they're like I've seen the TV shows. I'm aware of, there's a big industrial military complex system. There's a lot of states that their economy depends on these military and contracts, and so I wouldn't, and I don't think it's no one should be like uncomfortable of showing anything, because if it's just for the health level, you can, for the economic level, for the collective benefit of society, there's also national security benefits that you can do, and you never know whose lives you can improve or which lives you can save. So I've never felt comfortable. I don't think anyone should. Thank you.
Yeah, I also had another question. So I saw that like you do patent writing and researching. So like I was really interested if you could like talk about that for a little bit, like what goes into that and like what exactly do you do?
That is when science stops being fun and starts being more lucrative, and so and that's nothing to do with the military. And most of the things 99% of things that you patent, that you have intellectual property, whether if it's a university, whether if it's a private company, a combination of both, and a private person, 99% of those great ideas don't ever even come to real life. So when someone asks me, I think one of the first questions, when are we going to have technology that can measure a concussion as fast as we measure temperature? Probably it's being already patented. You can go to United States, USTPO, United States patent, and also Google World Organization patents. You can see the amazing technology with drawings, with sketches, without data. Okay, just theoretical, that has been patented. So it is a curve of excitement. At the beginning, you feel very, very excited because you think, oh my God, I'm gonna have this idea and I'm gonna, write it and I'm gonna change the world. Sort of like when you start the PhD, but unlike the PhD, it's not that gratification, because there's a lot of science decreases a little bit, and law and legal arguments increases way more. So if you have a great idea, and there's only so much I can reveal for purposes of, but let's say if you have a great idea for Huntington's disease and you think there's a remote that can actually, control how a computer measures Huntington's disease, their walking ability, or they are experiencing a heart attack, so you can treat it even before they suffer a condition, which is what we do a lot of the predictive medicine. The best disease is the one you can predict. The best condition is the best treatment is the one that can treat a disease before even happening. But the problem with with patents and intellectual property is that there is less. There's a point where the legal arguments outweigh the science arguments, and if you have a great idea, this Huntington's disease, just come up with probably exists. If there's slightly overlapping with an idea that someone had in another country 10 years ago that you've never met and you never hear, the patent doesn't go through, and it goes into a lot of primary and secondary questions and back and forth that sometimes can get expensive and tiring. And but just like grad school, you shouldn't feel discouraged, and it's a long-term game. The creativity and the innovation, that's the part I love. The process, not so much, not the sequence, to be completely honest. But that, you always work with a lawyer. You always have your legal team, your paralegal, and they might, you ask them, they might be, they might feel very different. They might say, patenting is so great, because they are more within the law and the legal arguments and that back and forth that lawyers have and that neuroscientists have sometimes too. It's just sometimes the benefits, the motives are different. Yeah, great question.
Yeah. That was very insightful. Thank you for answering.
No, thank you. I will say though that patent with a private company is easier than with a university. When you have an idea, an original idea with a university, especially if it's a public university, the university will always want to make revenue out of it. And sometimes when you work for a university, you think they're completely entitled to your ideas because they were based on the ground. So it is harder to patent something with an academic. It's less expensive, but it is harder to materialize it and to see the revenue or the fruits of your idea actually being materialized in academia than it is private, which is, I always, I think it's good if you're interested in it, pursue a master's, pursue a PhD, and then go and work in a private company and write all your ideas somewhere and,
Yeah, definitely. Okay, if anyone else has any other questions, just feel free to ask them. And if not, we'll just wrap up soon.
I had one quick question. So if you don't mind sharing, what really motivated you to go into the field of neuroscience?
I grew up with my grandfather with Alzheimer's and a great uncle with Parkinson's, and I had a friend that had a brain injury. He was 15. He was after a party, he was on a car on the back row seat in the middle, and something happened. There was a big, stop, and because he was in the back seat in the middle, he didn't have a seat in front of it, so he went up and jumped completely into the window and crashed his forehead. That's what it looks. It looks like the person just, like my friend just damaged his forehead. I remember thinking, oh, now you're not gonna look good, for the next 2 weeks if he had a big scar. Little did I know that he changed his personality dramatically, that he changed his emotion dramatically, even though for teenage purposes, when you have a lot of hormones in the neurons. And that made me interested into what happened. I thought it was just the forehead, and you read and you study science. And I was in medical school for 2 years in Venezuela, right after in most countries. But then you start seeing what the neuroanatomy class, it's really interesting when you're in a class and it teaches you a life lesson, and it teaches you the why, and you're like, oh my God, that's why. I think I even said it in class, like when they're like, oh, that's why. And we're like, Luigi, what are you talking about? But that's what happened to my friend. He, during development, he had a big injury in the prefrontal cortex. That's the part that actually regulates or inhibits or downplays your limbic system, which is the primitive system where emotion and aggressions and sexual drive is. So it was important for me to realize how much neuroscience was around me, for either the older people in my life, the family members, the friends that I've lost, because their personality changed. My friend, I don't even know what happened to him. I hope he's okay, but he ended up, dropping out of school, arguing with his, he changed completely. He was an A+ type of guy. He played soccer, world football very well, and it just sucked how one single moment, you just sit in the car and the worst, it's like an airplane, and no one else in the car had a problem. I wasn't friends with anybody else that was in the car. I wasn't invited to that party, but that one moment completely broke, and because even like by the time he got to a neurologist, it was like 8 months after. And he got to a neurologist after he went seeing a psychiatrist, because there was a taboo that if you suffer confusion and irritability and emotional problems, then you're absolutely crazy and you have to see a psychologist and then a psychiatrist. And a lot of people, even in Venezuela, and that was the good old days of Venezuela too. A lot of people see the connection that like nobody wants to have an emotional issue. Nobody wants to be depressed. Sometimes patients that see a psychiatry and and this happens with people that suffer ADHD, they really need to see a neurologist. And sometimes the opposite too. Sometimes people are with neurologists, they have to see a psychiatrist. But that lack of information, that collective awareness, it was an affluent, college-educated society part of my city, and just still suffer from the basic ignorance. That motivated me to do really well in the neuroanatomy class. And I always said I wanted to be a neurosurgeon or a neurologist when I finished med school. Then, crisis happened. I went to study college here, and I said, I want to be a researcher. I want to be a neuroscientist. What can I do? There's pre-med, there's pre-law, there's pre-vet, there's pre-dental, but there's really no pre-neuro. So the closest thing you can do is what I did, which is psychology, biology, then do a master's in neuroscience. And then when it goes time to do the PhD, then you decide if you want to pursue a traditional basic neuroscience PhD or a more clinical, translational, applied neuroscience PhD like I did. But yeah, it's been a part of my life.
Thank you.
Yeah, be careful when you're driving in the car. You're about to fall of that area. That was a very, very like drastic example, but it's jumping from a car, but it happened, and it happens every day. And there's a lot of people that had a brain injury in that moment. They diagnose it, but they don't manifest the worst symptoms until weeks later, until months later. And sometimes they don't even account to that. A scar in the forehead is not always scar in the forehead. That's what it's fascinating what the brain does, how it works, the redundancy in it. Like you have, at the same time, you have people that suffer stroke or suffer big injuries that they get removed the entire frontal lobe, but they don't experience that many emotional symptoms as my friend did. It's just, I think it's amazing. I think it's worth pursuing. I always like neuroscience, just about school, taking classes. A lot of the classes are not lecture driven. They're not like a professor, this is what it is. A lot of the classes are, this is a paper, and it could be annoying, a 16-page paper, but a lot of the classes are discussion, which is unbelievable because it gives you a chance of you of you dictating the lecture, of like, this is what I think, this is how I see the data, this is how I see the science, and it gives you an opportunity. It's very different from college and from high school, of having the professor, having the monopoly of the truth. It gives you a chance, neuroscience gives you a chance to learn, to grow, and to be able to discuss your own ideas. Thank you.
I mean, yeah, thank you so much for sharing that. I really can't imagine what you must have gone through, but I think in your work, your work reflects that a lot. So I kind of wanted to ask another question. So you mentioned that you founded the Ibarra exchange. So I was wondering if that was also a factor in founding that.
Yeah, absolutely. The Ibarra exchange came because of COVID. When COVID started, everybody, for some reason, and you see it on the news, domestic violence increased, mental health increased. Mm-hmm. You see a lot of, regardless of the number of deaths that were dying and the number of cases because of the infection, there were also a lot of cases of people that were dying because they were taking medication over the counter. They were just grabbing all the Mucinex and all the Benadryl they can take and thinking they could kill the virus. It would be nice if they can show those numbers on television too, but there's been a lot of complications in deaths and for individuals that have not suffered the virus by itself. But it was also a big motivation. My life, my grandfather did pass away in January. My great uncle with Parkinson's did die a year before I started grad school. But the motivation was people are overthinking too much, and I understand we are from our life completely changed 180, a lockdown. We're actually receiving less, and now there's research on it. We're receiving less natural light and more artificial light. That both things are damaging. Receiving more artificial light and less natural light. Both things are contributing to conditions. But there was a lot of, you see, a lot of divorces, a lot of people making life decisions, a lot of people making, changes dramatically completely. And it's just that we have been in a constant stress, in a constant trap, and an upside down. That the thing that makes it more stressful is that we don't really see an end. Remember, in March, they said, by June, it should all be good. Now it's October is tomorrow. And, the second wave, what second wave? We're still in the first wave. So the Ibarra exchange was a way of saying that, let's understand the difference between obsessive compulsive disorder and the difference between a psychological stress that you're experiencing for COVID, having these rituals and exposing yourself to these constant repetitive thoughts, disruptive thoughts, and checking the electricity and the light within your house 25 times a day. That could be OCD, but that also could be, boredom, stress, and the new environment, the new reality that we're living in. So I wanted to have an opportunity to be able to discuss that in both languages. And also, I got annoyed, to be honest with you, and I say this loudly, when you see in television journalists asking epidemiologists or scientists about what is happening, and because it's a journalist that's usually a lawyer, working as a journalist, working, very partisan, there's no pushback. You can have a pharmacoepidemiologist, a pharmacoeconomist, a disease expert, and they might say something wrong, and there's no pushback because the journalist doesn't have the science information in order to contradict or to point out. So I think I like the idea of scientists interviewing another scientist, a doctor interview, people that are in the field interviewing each other, so people can get the best accurate information.
All right, yeah, we are so sorry for your loss. And we really appreciate this meeting. I think talking to you was a really valuable experience because we got to learn about you and the work that you do. I think it's very inspiring, that you work towards making change. And I definitely feel like we need more people like you and with your motivation, of course. So I believe there are no other questions for now. So if anyone has any last burning thoughts or burning questions, just feel free to say them. And if not, we will wrap up.
Thank you so much for your kind words. If future questions, they can always ask you. Feel free to email me. That's my personal email.
Yeah, definitely.
I'm always happy to answer a question, and don't ever be scared of saying I don't know. Like that happens in neuroscience. Feel like I don't know, I don't have the answer yet. Maybe no one does. But you know, if you pursue neuroscience, pursue it with an open mind, pursuing that there are people there that have good motivations, that may have similar life experiences, and don't be scared to say I don't know. Don't ever be scared of asking questions. As a good professor always said, in grad school in neuroscience, there's no such thing as a stupid question, and there's always a time to ask a question. You know, before, throughout the lecture, after, when you see someone in the hallway. So thank you for that. Thank you for the invitation, and hope to keep in contact. Thank you so much.
Yeah, definitely. It was great meeting you. By the way, his email is in the chat, 15 Play's email in the chat. So if any of you want to contact him, just feel free. And if not, I guess we'll end it now. So once again, thank you so much for being here. We really appreciate it.
Likewise. It was an honor.
All right.
Thank you so much.
Bye-bye.
God bless.